Good evening, everyone. So, today's video is about designing a knuckle joint. So, as you can see here, the knuckle joint is basically used to connect two or more rods which is subjected either to tensile or compressive force, and the two rods are need to be fastened together. As already seen in this figure, their axes are not need to be aligned, but they need to meet at this point. So this knuckle joint allows small angular movement of one rod relative to another. And one more important feature that distinguishes knuckle joint with the different types of joint, for example, quarter joint, is that quarter joint cannot be easily connected or disconnected, but knuckle joint can be easily connected and disconnected by removing the knuckle pin. So we are going to see the components in detail. So first of all, this particular bigger portion is called fork end and the smaller portion is called rod end, and this is called pin, or it can also be said as knuckle pin. On the other side there is one collar and there is one taper pin. So this complete figure is the exploded view of this knuckle joint assembly. So in order to connect the knuckle joint together, first fork is been there, and this eye end is also called rod end has been inserted inside the fork end, and they are kept together by means of knuckle pin having diameter equal to the diameter of the hole which is there in the fork end as well as on the eye end. And there is can be one collar located on other side of the fork, and it has a small projecting hole which matches with the hole which is there already in the knuckle pin, and the two holes are made concentric, and this taper pin acting as the locking mechanism to secure the collar with knuckle pin in order to keep all the parts of the knuckle joint together. So this is the complete assembly how it looks like. So as you can see here, there are different parts: single end rod, that fork end, and the collar is there at the top, and one lock pin is there. Okay, so there are certain empirical relations which is used, like D1 here stands for diameter of knuckle pin. This diameter is the diameter of knuckle pin. Next is the outer diameter of eye. That means this bigger portion, which is here given by in this example as 52. So that particular diameter is designated as D2, has been taken as twice the value of D1. Then there is a third diameter of knuckle pin and collar. That is this bigger portion, bigger diameter which is there at the knuckle pin. That is called that diameter is designated by symbol D3. It is taken as 1.5 times the diameter D1. Now moving to the thickness, small tt, small symbol t is taken as thickness of single eye or rod end. So from the exploded diagram, this is the rod end. So that thickness, which is shown here by this numerical value 30, has been designated by the symbol small t. And that t is taken as 1.25 times d. Okay. Now next comes the thickness of fork. So from the exploded figure, this complete portion is called fork, and this individual thickness, in this example it is marked by the numerical value 18. So that T1 has this value, and T1 is calculated empirically by the value of 0.75 times the diameter of shaft. That D is the diameter of the rod or the shaft which is connected by the knuckle joint. Then there is a thickness of pin head. Pin head, that means the bigger diameter which is there at the knuckle point. That simply will looks like a head, therefore it is abbreviated as knuckle pin head. It is given by the value of T2 that is equal to 0.5 times the diameter of shaft. So this is the one figure which shows the different values, which is also data like the length of the fork is taken as 4.5 times the diameter, whereas for rod end it is 4 into diameter. Okay. So coming to the failures, in order to design the joint and in order to sustain it against the given type of load, we need to consider the different types of failure criteria, so that for the given dimension the knuckle joint will not fail in its operation. So the different values that we are going to consider in the numerical formulas are shown here. So P will be the tensile load which is acting on the rod. D, D1, D2 are the diameters of the rod, pin and eye, whereas T the thickness of single eye and T1 is the thickness of fork that we have already covered. Now, knuckle joint is mainly subjected to three types of stresses. Number one, tensile stress, which has been shown here by the symbol of sigma T. Second, shear stress, designated by the symbol tau. And finally, the crushing stress, which is designated by the symbol sigma C. That is the given as permissible stresses for joint material in tension, shear and crushing. There are two assumptions made in the failure of knuckle joint. Number one, there is no stress concentration. And number two, that the load is uniformly distributed over each and every part of the joint. The two main assumptions are there. Okay. So coming to the first criteria, failure of solid rod in tension. The two rods which are already there in tensile loading are connected by means of knuckle joint. So in order to find the diameter of knuckle joint, we will consider the first tensile criteria. So if you look at the formula closely, it means as the same value as sigma T is equal to P by A. Therefore, P is written as area into sigma T. But the shaft is circular in cross section. Therefore, it is given, area is given by pi by 4 d square. So the complete formula P is equal to pi by 4 d square into sigma T. Okay. From this equation, we will find the diameter of the rod or the two shafts which is connected by means of knuckle joint. Second criteria is the failure of knuckle pin in shear. So, if you look at the extruded view of the knuckle pin, you will find that knuckle pin has been held by two portions, one by fork and other by eye end. So, that fork is, if you consider the tensile loading of these two joints, fork is when pulling the knuckle pin to its side, that is, we can say to the left side, and the eye end is pulling the same knuckle pin to the right. So the resulting effect may produce, and it will reduce the pin, and it will break the pin in three pieces, whereas one piece will be there in the eye end and the two pieces will remain in fork. So this particular failure of knuckle pin into three parts is been defined by the phenomena of double shear. Therefore, the cross-sectional area will be also double. So that will be 2 into pi by 4 d1 square, where d1 is the diameter of knuckle pin. So same formula will be there. P is equal to area into stress. Therefore, P is equal to area 2 into pi by 4 d1 square into tau. Because stress generated here is shear. From this equation, you can calculate the diameter of knuckle pin. So earlier on, we have taken the empirical relation to calculate the diameter. So this calculation is also valid, or you can use that value and you can check the stress generated, and it should be less than the given permissible values. Both are possible. So number third is, this is the third criteria, or we can say additional criteria for checking the design of knuckle pin. As it is shown here, one portion of knuckle pin will be there in the eye end, causing a uniform load, whereas the portion of knuckle pin which is there inside the fork experience a uniformly varying load called UVL. So if we take the resultant of this particular types of load and using the equilibrium equation, we will find that the maximum stress which is generated in the knuckle joint will be equal to will be given by this formula. So from this expression we will again find the value of d1. So we will now have two values of d1. One find by this formula or by empirical relations, and second by bending stress. So we need to take always the maximum of the two values. Okay, so moving to the next criteria. So now we have designed the shaft, we have designed the knuckle pin in shear and bending. Now we'll move to the third component, that is single eye. Now again moving to that particular thing, single eye is this portion. So there are three permissible stresses in the joint, namely tensile, shear and crushing. This particular single end experience all three types of failure. Now here again the formula is nearly same, load is equal to area into stress, but now the area is not circular because the loading is occurring at the axis which is not there at the cross sectional area. T1 into T into sigma T. Okay. So that is the resisting area. So if you look at this complete simple figure, so D2 is the bigger area and D1 is the smaller area and T is the thickness here. So that is a simple formula which is like width into depth. Okay, so P is equal to area into stress, where the stress is the tensile stress because of tensile loading. Now moving to the next criteria, that is failure of single eye due to shearing. Again, because the load acting is the same tensile, but due to the tensile loading, the stress can generate in the form of shear load. And again, the resisting area will be same. Only the stress generated will be shear. So then the formula will be P is equal to D2 minus D1 into T into tau. Now the third and the final criteria for single rod end is the failure of single eye or rod end in crushing. So the single eye or eye pin may fail in crushing due to tensile load. Now crushing is the phenomena in which the pin which is holding inside the hole in the single end may experience certain crushing at the contact surfaces, and for the same reason, for considering the crushing criteria, we need to take the contact area instead of peripheral area. So contact area is being given by the diameter multiplied by thickness. D1 is the inner diameter of the single eye and T is the thickness of single eye. And the failure criteria is again given by the same terminology, that is D1 into T into sigma C. So from this equation, the induced crushing stress for single eye or pin may need to be checked. So we have seen all three formulas, but in this formula you are not going to find anything, but you need to find the value of sigma, tau as well as sigma C. This value should be less than the permissible stress which is already given in the problem. Then only your joint is safe. If any of the value increases, you need to redesign your joint. Okay. So now moving to the final component, that is failure of forked end. Again, the forked end experience three types of failure, namely tension, shear and crushing. The forked end or double eye may fail in tension due to tensile load. Now in this case, the resisting area is been double because there is an area resisting at the top. 1 minute. There is area resisting at this thickness, and also there is area resisting at the bottom thickness, and this particular fork is subjected to tensile force in this side and also to this side, due to which there can be tearing of the joint. Okay, so we need to first calculate the resisting area. So this is the outer diameter minus inner diameter multiplied by thickness, and similarly for this outer diameter minus inner diameter multiplied by thickness. Okay, the total resisting area will be summation of two area. That's the reason it has been here written as P is equal to D2 minus D1 into 2 times T1. So this will be the area multiplied by stress. Again we need